Today we'll begin lesson 9.3, which deals with the finding the surface area of pyramids. Last class we did prisms with our rectangular prisms and triangular prisms. Today we're going to look at pyramids. So we'll still with polyhedrons, but we'll move on to pyramids. So what we look at first is that we need to be able to differentiate between what's the height of a pyramid and what's the slant height of a pyramid, which is something we discussed briefly last class. The height of the pyramid is the distance from the vertex straight down to the base. Now, again, we have to measure perpendicularly because that's the shortest distance. So in this case, the height of this pyramid is 21. That's the height, which we would label as h. Now, this distance from the center of the base over here to the base edge is 20. Now, the whole thing is 40, so that distance is 20. And then this guy over here running down this lateral face, that's the slant height. We use the abbreviation of SH for it last class. So what we have within this triangle is we have a height of 21, we have half the base edge of 20, and then we have the slant height here, which I don't know, I have labeled as an x. Well, what we did last class is we used the Pythagorean theorem to calculate the value of x. So what we're going to do is we would have 20 squared plus 21 squared equals x squared, and we would go through the math and crunch the numbers on this guy, and we would find that that slant height has a length of 29 meters. Now, the thing about that slant height, it's several things, okay? If you look at it, yes, it's the slant height. The other thing is, it is the hypotenuse of that right triangle, so it's going to be longer than 21 and 20. And it is also, if you look at this face over here, at that triangular face of that pyramid where that base edge is 40, and here's your slant height, that's also the height of that triangular face. So if we were to calculate the area of this triangular face over here, we would need to know that slant height. And then all we would have is 1/2 times 40 times 29. We could calculate the area of that triangle. Now if you visualize this, the area of that triangle, we actually have 4 of those triangles around that pyramid. And that's what we're getting into today. So on number 2, here's the height. That height is x. Now here's this distance. This whole side is 16, so the distance from here to here is half of that, which is 8. And then in this case, we know that the slant height, now here's the slant height, we know that that slant height is 17. Okay, so we also know that that slant height is also the hypotenuse of that little triangle. So when we set this one up, it would be x squared plus 8 squared equals 17. Again, you crunch those numbers in your calculator, and you would find that the value of x would be 15, and our label would be 15 inches. Right. So let's get into calculating the surface area of these guys. Now we need to, again, make sure that we can differentiate between the slant height and the height of a pyramid. Now, if we would go to drawing number 3 and we look at it, the height is the distance, the perpendicular distance from the base to the vertex. Again, the reason we measure perpendicularly is because it's the straightest distance. And the slant height is the height of the lateral face from there to there. Now we could actually draw that slant height right here in the front. That would be the distance from here right down to here. I like to draw it this way so that triangle looks a little bit prettier. Again, we could draw a slant height down each side. So when we go to calculate surface area of this guy, we do it kind of sort of like we did last class with a twist. Alright? Now what I'm going to do is I'm going to pull that little handy dandy right triangle that's out from inside there. Okay, so this would be this triangle that's right in here. Whoops. That would be this guy right here. Got a little tall, but that's okay. So if we look at this guy, I like to redraw this base. Now here's the trick. What's the distance from here to here? Well, that's 3, okay? So we may need to do some Pythagorean theorem here. And if you notice, this is at 3, 4, 5. Right here, I don't, because I have everything. So what we're looking at then, and what I like to do with this guy, and I'm going to sketch this guy right here real quick, is the base of this guy is a little square. Notice that square right there, and it has dimensions 6 by 6. Okay? Now what I'm going to do, if I were to cut along these lateral edges, and I were to lay this guy down right here, I took this little triangle, I cut it, and I laid it down. I took this one, laid it down, kind of like I'm peeling a banana, and I laid all those sides down. What's going to happen is I'm going to have that base that's a square that's 6 by 6. Then on top of that, kind of laying down here, I'm going to have these little triangles shooting off here that are all the same. Now these are those lateral faces of this guy. And what I always say, it kind of looks like that throwing star. So what we have is we have all these triangles laid down where they each have this base edge of 6. But what you need to be able to see is what's this height right here. The height of that triangle is actually that 5. That 5 right there. Everybody always thinks 4, 4, 4, but once you lay these guys down, that guy becomes flat. It's two-dimensional. It doesn't have that height anymore. And really, today, we're not concerned with that prism height, that pyramid height, and we won't be concerned with that until we do volume. Right? So if we look at this, what we have is we have 1, 2, 3, 4 of those lateral faces. Now what you can say about these guys, because this is a square, all 4 of these are the same. Now to do that, we're going to calculate the area of that triangle. 1/2 times the base, which is 6, times the height of that face, which is 5. Now if you do 1/2 times 6 times 5, you get 6 times 5 is 30. Half of that is 15. Now if you look at this, you have 1, 2, 3, 4 of those faces. So it'd be 15, 15, 15. Well, the quick way to do that is we have 4 of those faces. I'm just going to take it times 4. So it's not the same times 2 as we had last class. Now 15 times 4 is going to give us an area of 60 square feet. Now what we did was we calculated the area of all these triangles around that base. What that actually ends up becoming is that is the lateral area. This part is. It's all 4 of those triangles. Well, now to calculate the total surface area, which is all I'm concerned with today, we just need to find the area of that base right there. Well, that base is a square with dimensions of 6 by 6. Gives me an area of 36. Now, if you look at that pyramid and think, how many bases does a pyramid have? It only has 1. So we just only need that 36. So what we have now is we have our lateral area, which is 60 square feet, plus my surface area. I'm sorry, plus the area by base, which is 36, which gives me a total surface area of 96 square feet. So that's the answer we're looking for. We're not just concerned with just lateral area. We're concerned with everything. All right, number 4. Same process, and again, what I'm going to do is I'm going to kind of copy-paste this guy over here. I like kind of looking at this guy the way it is there. So I'm going to go ahead and look at this guy, and I'm probably just going to copy it over here. Let's do that. Copy-paste it. Boom. Okay, we're going to look at this picture right here, and that's just a picture of what that would look like again if I cut along the edges and I laid each one of those sides down and kind of peeled it like a banana. Now, each base edge down here is 10 by 10. So again, you can see that square is 10 by 10 all the way around. So you kind of get an idea of what the area of that square is. You can see, well, 10 times 10 is 100. We'll get to that when we get to it. Now here's the question. What is the height of these lateral faces? Now remember, once I lay these guys down, that 12 is gone. There is no more height. So the height of that lateral face, that 13, that slant height, that's this measurement right there. That's the height of the lateral face. So when we go to find the area of this triangle right here, we're going to go 1/2 times the base, which is 10, times the height, which is 13. Now, throw that in your calculator, and you would find that one of those faces has an area of 65. So this guy has an area of 65, this guy has an area of 65, 65, 65. So what we're going to do here is we're just going to simply take that times 4, and you find that that's 260 meters squared. Again, that's not the total area. What this is the lateral area. Okay, those triangles around there are the lateral area, but what we need to do is we need to add in the base. Well, the base has dimensions of 10 by 10, which is 100. How many of those bases do we have? Just the one. So I'm going to slide that over. So there, my lateral area, 260, plus the area of the base, 100, gives me a total surface area of 360 meters squared. Right? So again, let's jump to number 5. Actually, let's skip 5, and I'm going to go on to number 6 and just look at number 6. Now, if you notice the difference between this one and the last few that we've done, we do not know the slant height. So what we need to do is we need to think, how can I pull that guy out? How can I calculate that? So what I'm going to do is I'm going to pull this little triangle out that we have right here. There's that triangle. I'm going to slide it out. Now we know that the height here is 3. That I know is 3. Now what we're looking at, what's the distance from here to here? Well, this whole side is 8, so the distance from here to here is 4. And we need to calculate that slant height, which is actually the hypotenuse of that triangle, which is also the height of that lateral face. Well, this one's short and sweet. You should know this one. We throw that in the Pythagorean theorem, 3 squared plus 4 squared equals x squared. That would be 25 squared is 5. So that slant height is 5. So we can go ahead and put that in our drawing now. That this would be 5, and this part would be 5. Alright, so now what we're going to do, we're going to look at this drawing again. So I'm going to go ahead and grab this drawing here. Oops, let me take a snip of it. So again, what I'm going to do is I'm going to kind of sketch this as if it were laid out, kind of like we did last time. So there's my little throwing star that, again, the base on this guy would be 8 by 8. That would be this guy. So you can kind of start thinking that, well, that area, that base is 64. Now these triangles have a base of 8, but what's the height of those triangles? That's the slant height, the 5. Remember, once I lay this guy down, that height of the pyramid disappears. So when we go to calculate the area of the face, it's area equals 1/2 times the base, which is 8. So we're going to find the area of that triangle, times the height, which is 5. Well, that's half of 8 is 4. 4 times 5 is 20. Now, again, we need to think, how many of those triangles do we have? Well, we have 4 of those, so we're going to go times 4, and the total area of 80 centimeters squared. And then we look into the base, we just have that one base that has dimensions of 8 by 8. Gives me an area of 64. So I only have one of those. So remember, this part's my LA, and then we add on the base for that total surface area. So we take 80 plus 64. It gives a total surface area of 144 centimeters squared. All right. Now the only change on number 7, again, we have to do that calculation of, hey, that's 7 squared plus the 24 squared, because we need the slant height. We need that slant height, so we'd have to do Pythagorean theorem real quick. And then the other thing that we have on number 7 is the no base. Now this one's actually easier because I don't have to worry about this last column. Like on the last problem, we did our area, we did our lateral area, and then we had to go to the base. Well, I don't have to do that if there's no base. You don't even have to worry about that part. So on number 7, that's all you do. You just find the area of that face, 14 by whatever your slant height is, 1/2 times 14 times that, and then times 4. You'd be done. Now what I want to look at is number 8. This one's a little bit harder. It's different because if you look at this guy, I have a rectangular base. Meaning, when I look at this guy, I have a rectangular base, so I actually have 2 different slant heights. So what I'm going to do is I'm going to draw these different lateral faces. Kind of show you what it's going to look like once we do that. So again, we have these 2 lateral faces are going to be the same. And then these 2 lateral faces are going to be the same. So we have 2 different pairs here. So like the last ones, we don't have that times 4 because I don't have 4 equal sides. So what I'm going to do is kind of slide this over, and I'm going to look at the faces separately. So this chart is not going to work on this problem. Okay, we're going to have to finagle a little bit. I don't have 4 of the same faces here. So what I'm going to do, I'm going to go faces and faces, and I'm going to have 2 of each. And I'll slide that bases down, and I still do have 1 base here. Okay, so again, that gives me my 5 faces. Now if we look at this, this would be 16, this would be 10, this would be 16. Now here's the trick to this. What's the height of this lateral face that touches the 16? That'd be that 7.8. And what's the height of this lateral face that hits the 10? That would be that 8. So what I'm going to do is I'm going to look at the area of this triangle right here and know that I have two of those guys. So I'm going to take 1/2 times the base, which is 16, times the height, which is 7.8. That's going to give me the area. That's going to be 62.4. And now remember, we have two of those, so I'm going to go times 2, and that would give me 124.8 total inches squared. Now that's for these two faces, this triangle and this triangle, because those two are the same. Now I'm going to focus on this face and this face, which are the same. We're going to do the same process, 1/2 times the base, which is 10, times the height, which is 8. Half of 8 is 4. 4 times 10 is 40. Now how many of those do we have? We have two of those, which gives me a total area of 80 inches squared. Now what we could do is these two guys would be my surface or my lateral area. But we need to add on that base. Now remember, that base is this rectangle at 16 by 10. It's just a rectangle, so we would just go 16 times 10 gives me an area of 160. We only have one of those, so it's 160 inches squared. Boom. So there's our area calculations. Now we just need to add them all together to get the surface area. That would be 204.8, so that'd be 364.8. 0.8. Now my label, inches squared. So there's the total surface area with a rectangular base. Now that guy's tougher because we have two different pair here that are the same. Right? So your homework will be to do lesson 9.3, the worksheet. There's no Math Excel. Just lesson 9.3 worksheet. If you notice on the worksheet, if you flip back, you can pause while you flip back. I believe it's number 11, the Luxor problem. The Luxor Hotel in Las Vegas is a square pyramid. It has base edges of 800 and a height of 300 feet, so you would have to calculate the slant height. And now when you're thinking about that, if it's covered in glass, the four triangular lateral faces are glass, but the base of the hotel is not glass. So you may want to make a note on number 11 that there's no base on that guy. Also on number 12, the roof to the cover at the park, you will not shingle the bottom of that as well. So if you have any questions, come see me in seminar, and thank you, and good luck.